right. Hello. Welcome. This is the mock test 2 solutions video. I'm going to kind of talk about what a lot of people did wrong on these, because a lot of people did a fair amount of things wrong on these, so we're going to try to figure out how to do that stuff right. And sweet, found myself faster than anybody commented. Feels good. I'm imagining we're only going to have 10 to 15 people here for this, but ideally, all 60 people who took the mock tests and spent my time to grade show up. Hey, Michael, welcome. Now, these questions might not be in the same order as when you took it, because I scrambled the order on the actual mock test form. So they're all in a slightly different order. There are only 3 questions, though, so they couldn't be too different. I would say the number one mistake for people who ultra flubbed this was they didn't use a calculator and they got the fraction question first. And they spent a million years doing the quotient rule. And after 15 minutes of doing just part A, which you're supposed to put in a calculator, they did not have enough time to finish their tests. So, feels bad. Hello, Isla. So if you can't tell, we're going to start off with the graph one, which was pretty rough for a fair amount of folks, but luckily it's pretty nice to go over because there isn't a ton going on there. Almost all the questions can be solved without really doing a ton of work, besides the first one, which does require work. All right, I think we'll begin now. So on the first question, it says find the average rate of change of g from -5 to 5. Here's what almost everybody did. They ignored... Oh, I'm not in Screen Sketch. They ignored g. Almost everybody answered this question for f, which was not what the question was asking. G is the integral from 1 to x of f of t dt. Which means we actually have to find the integral. So the first thing we know is because the bottom bound is 1 here, if I put a 1 up here, I get the integral from 1 to 1, which is 0. So I know g is 0 at 1. And to figure out the other values, like g of 5, I'm going to have to find the area under the curve. So I split this up in terms of a triangle and a rectangle. That's 8. And this is half of 8, or 4. So g of 5 is 12. Now, for the other side, I have to go from 1 to -5. So if I find the area of these dudes, 4 by 3 is 12, halved is 6. This guy is area 1/4 pi 2 squared, which is pi. 4 times 1/4 is 1. And then this little tiny triangle here is just a -1. I guess these are all negative. I should put that. Because they're all below the axis. But that's 1 by 2 and then halved. And so my area from -5 to 1 is -7 for -6 plus -1 minus pi. However, our integral is from 1 to -5, not from -5 to 1. So this would be the integral from -5 to 1. But we have the integral from 1 to -5. We flip the bounds. So if I want that, I have to flip both of these and get 7 plus pi. And now all we do is we're finding the average rate of change. So we do y2 minus y1 over x2 minus x1, like so. Almost everybody got the bottom of this right. It was the top where things were not good. And if you do this, you get 5 minus pi over 10. or about, like, what is that, 0.18 something. So that was A, and A was a bloodbath for most folks. So that was that process. So I had to do some math here to figure out all these different parts, but it wasn't too bad. It was just areas. All right. Find the instantaneous rate of change of g with respect to x at x equals 3, or state that it does not exist. A ton of people said it doesn't exist because that's a cusp. But that's f again, and this is asking about g. And the derivative of g is f. So it's just the value of the graph at that point, which is 4. And that was it. That was B. All right. C. On what open intervals, if any, is the graph of g concave up? Okay, for this, it's literally just, this is a derivative graph. F is the derivative of g. So where f is increasing is where I'm concave up. Those two. 0 to 3 and -5 to -2. Done. Now you would have to justify this on the AP test. You'd have to say f is increasing and f prime equals g double prime. Something like that. For justification, I guess f prime of x equals g double prime of x, or something like that. The point is, you just have to show that you know, like you knew to look for where the graph was increasing. And our last one says, find all the x values at which g has a critical point, classify the critical point. For this, since this is a derivative graph, we look at the zeros. There are 2 of them. This one is neither, because the slope does not change sign. F does not change sign. It doesn't switch from negative to positive. It switches from negative back to negative. And this one goes from negative to positive, so that's a minimum. And that's it. That was all there was to that question. So for that one, you literally got a point for realizing that it was the zeros that you were looking at. You got a point for identifying the 2 values, x equals -2, x equals 1. And you got a point for correctly evaluating them, neither and minimum. And for our reason, negative to negative, negative to positive. And this would be totally enough to get all the points there. So that I thought that question was, besides A, relatively easy. I thought B, C, and D were pretty nice. So if you didn't consider them easy, I'd try another question like this to see if you can use the things you learned from this to apply it to that and do better. All right. Let's move on, since I don't see any questions, to question 2. Okay, for the next 2 questions, I'm going to be using a calculator a lot, and by a calculator I mean Desmos. So what I did for this was I just put this function in here. F of t equals blah blah blah, and then I just figured it out, took its derivative in Desmos without doing any hand math. Or this is perhaps even easier on your calculator. You have to finagle a little bit in Desmos. And then I plugged in 5.1 and boom, answer. That was it. So there was no work shown on this one. This was just a straight 1 pointer. It's just 6.492. And that's it. So if you missed the opening part, I said a lot of people lost points because they tried to quotient rule this and spent 15 minutes on the question. Which, A, if you spend 15 minutes on a single part of one of these questions, you've already messed up horribly because you've wasted a bunch of time you could have spent trying other questions. So just never do that. The second you start spending more than 5 minutes, say, I'm going to table this, I'm going to come back. All right. B says, find all the values of t in the time interval for which the speed of the particle is 1. Now, 90% of people did not read this word and register what this means. Most people answered where the velocity of the particle is 1 by just graphing it and looking where it goes through, or Better yet, Desmos is really, really good for these kind of things. You can just graph y equals 1, graph the function, and then just see where they intersect by clicking on the point. It's really slick. But because it's speed, I want where velocity is 1 and where velocity is -1. Both of those spots. So if I go back to my Desmos here, I graphed y equals 1 and y equals -1. The graph that's graphed here is my velocity. And I can see between 0 and 2, so between here and here, I go through this one here, which most people got this point, like the 0 point something something, 7 something or something. But most people didn't get this point, which is also a speed of 1, because it's a velocity of -1. And if we click on those 2 points, see in Desmos we can just click on them. Whoops, not that one. We get 0.772 and 1.401. And that's it. So it's reading from the graph once you have it in. I'm showing these in Desmos because you get Desmos on this AP test. So if you don't have a graphing calculator at home, you can recreate everything I did in this just by looking at what I typed in over here. All right. Onwards and upwards. Part C says, find the position of the particle at t equals 4. Is the particle moving towards the origin or away from the origin at t equals 4? Okay, so to find the position, all we need to do is integrate the velocity equation from 0 to 4 and add our initial position, which is the initial position is that when t equals 0, x equals 7. So what I did was I went to my calculator, and I just typed in 7 plus the integral from 0 to 4 of my velocity equation given in the question. And if you do that, you get that the position now is 6.712. And thankfully, getting that position was 3 of the 4 points in this question. But the last part of the question was to plug 4 into the velocity equation, so that's what I did here. I just plugged 4 into my velocity equation. Whoops. Wait, y equals -10. Let's not do that. Oh, gosh. Go away. All right. And I got 1.213. So if my position is positive and my velocity is positive, that means I'm going away from the origin. It means I'm up here and I'm going this way. So that is away from the origin. And that was the last part of the question. All right, let's go back to our question. And part D says, does the particle return to its initial position? Now, most people try to give me a reason involving like the change over an interval and saying like it's negative at some point. The AP test did not give points for any of those explanations. I only gave explanations where people said, I found the point where it equaled it. Because a few people actually found the point. It was like 2.881 or something like that. Here's the way the AP test did it. They said, let's just try some values. So I'm going to take my position equation, which is this thing, and you can just change this bound up here to figure out what it is at a whole bunch of points. And so it's asking on the interval 0 to 4. And if I just look at the integral from 0 to 2, I go from 8.36 here to 6.855. And I know this function's continuous, so if it goes from 8.6 to 6.855, it has to go through 7. So they gave points here for did you sandwich your points? So did you sandwich 7 between 2 points that you know the graph goes through? And we can literally figure out where the graph goes through everything. It starts at 7, it goes to 8.8, it goes to 9.4, it goes to 8.36, and then boom, it goes through down through 7 to get to 6.8 and ends up at like 6.7. So that's the way they wanted you to show this, was to say, if I go back here, say something like, yo, f of 2 is 8.56 or whatever it was, and f of 3 is 6.84. So IVT, the intermediate value theorem, says it must go through 7. Because the particle's movement is continuous. So very few people use the intermediate value theorem for this, so it was interesting the only thing on the answer key was to use the intermediate value theorem for this. All right. And we're chilling. No questions yet? Wow, I'm actually kind of... I guess it's nice out today. I assume people are going to watch this later. All right, the last one is that I'm going to do is the chemical reaction problem. This could have been your first question. Okay, most people did this 3A right. The way to do it wrong was to plug 2 into this equation for y, because 2 is t, not y. So that was a little bit of a sad panda sort of mistake. But they do tell you at t equals 0, there are 10 grams. That's y. So what we do is we do negative 0.02 times 10 squared, and we get that the slope of the tangent line, notice how it says line tangent, so you should use a tangent line, is negative 2. And now that we know this, we know we start at 2, and then we're going over 2 at a slope of negative 2, and you get 6. And that was it. That was A. You just get 6. So I think that was a 2-pointer, one for getting 6, one for getting the right slope. All right. B says, using the given differential equation, determine whether the graph could resemble the following graph. This one has a very easy explanation. This is negative, which means the slope is always negative, because y squared is always positive, and it's multiplied by negative, so it's always negative. This graph goes up. So this is always decreasing. So this is trash. That was it. So that was a 1-pointer. Part C says, find an expression for y by solving the differential equation. Okay, so this was just a separation of variables question. I'm going to do it in the space down here. And all you were supposed to do was do dy over y squared equals negative 0.02 dt. The people who moved the negative 0.02 with the y squared almost all got this question wrong. Unless you took it out of the integral. It's definitely, like, leave any junk on the t side. Don't put it in the denominator if you can help it at all. So if we integrate this, we get negative y to the negative 1, because this is y to the negative 2, that we're raising the power by 1 and dividing by the new power, which is negative 1. So no natural log. Didn't see many natural logs, so that was kind of nice. This integrates the negative 0.02 t plus c, like so. Then we just multiply both sides by a negative. Y to the negative 1 equals 0.02 t plus a different c. We flip both sides. You get y equals 1 over 0.02 t plus c. And we use the initial condition that t is 0 and 10 is my y to solve for c. So c is just 1/10. And so that was the equation. You got full credit for getting to this answer. Or if you did it the other way, where you moved the 0.02 to the other side, you should have gotten something like 50 over t plus 5, I think, which is exactly the same. It's just multiplied by 50 over 50. So either of these answers was totally chill. All right. Our last one says, determine whether the amount of the substance is changing at an increasing or decreasing rate. Explain your reasoning. Okay, so we're looking for an increasing or decreasing rate, which means I'm looking for the second derivative, because I'm looking for the rate of the rate. So I got to take the second derivative. The derivative of dy dt is d squared y dt squared. The derivative of that junk on the right is negative 0.02 times 2y times dy dt, the chain rule part for the y. Okay, we know what dy dt is. It's this garbage, so we plug it back in. And we get negative 0.02 times 2y times negative 0.02 times ya squared. All right, negative 0.02 times negative 0.02 times 2 is a positive 0.00. How many zeros? Oh, lordy. 1 over 50 times 1 over 50 is 1 over 2500. Yikers. So this is that many zeros? Yeah. And I mean, mostly this doesn't care. All we care about is whether or not this is positive or negative. And the point is, it's positive. And all of our values of y have to be positive because we can't have negative amounts of a chemical. And the problem says, like, for y greater than 0. So is it increasing at a increasing or decreasing rate? The rate is increasing because our second derivative is positive. So even though the rate is negative, the rate is getting less negative, which means the rate of the rate is increasing. And so this was a increasing rate as the answer to this. And very few people got this right. All right. Okay, I kind of blazed through those because this was a 45-minute test, and I'm about 19 minutes into going through these. So I blazed fast. I didn't get any interrupting questions, but if you have any, feel free to shoot them. If you said increasing with not that reasoning, is it right? I think I gave you 1 out of 2 points on that question, Raquel, if I remember right. Because I believe it had answer and then justification as 2 different points. So you had a okay justification, but it wasn't very compelling, and this is the most compelling justification. So I think I gave you 1/2. I don't know how they'd actually grade that, to be honest. Maybe they give you 2, maybe they give you 0. Assign us more homework. I'm kind of running out of things to assign you. Honestly, if you want more practice, do the free responses in the Barron's book. Do the questions on the optional practice on the AP website. That's like next to the homework tab or whatever. Some people have found those. Do just free response questions off random tests. Anything you can find that looks like a question we've done and not an area volume question is fair game on any of those. And I think I got your question 3, Raquel. I looked through emails for anyone that had incomplete tests, so I'm pretty sure I looked at everybody. I will be streaming again on Monday, and hopefully people will watch this, because seriously, 60 people took this, and only 10 people showed up, so I'm hoping more people watched it than showed up. I'm hoping it's just a nice day. Because I want people to improve. And man, I think this mock test was actually easier for me to go over than the other one. So I think a lot of these things are just, you have to like read the question right, and a lot of people were reading it wrong, and you can absolutely fix that in 3 days. You can't like fix the entire mathematical process required to get it, but you absolutely can fix the interpreting the question correctly. All right. Well, yeah, it's sunny and 80 degrees out, so I guess I'll peace. Oh, sorry, I have another question. If the question says not calculator, but I use a calculator, will Andrew, they will not. I did not mark you off for like not giving exact answers and using decimals instead. But on the AP test, it's all going to be calculator because they have to assume open notes, open book, open calculator, all of that stuff. How many points out of 27 should you have gotten for a 5 on this? My estimation is something like a 16 or 17 is a good proxy for a 5. Is that a little low? No? That's probably about... It's probably 17, I would say. I'd say 18 for safeties, but yeah. But yeah, I honestly don't know how they're going to grade it this year, so... And yeah, Andrew, yours was really good. You answered a lot of questions. Like, you were definitely reading the questions correctly, which is good. Yeah, just to remind you of the breakoffs, like 60% and above is a 5. Uh, um, like 50% to 60% is a 4. 35% to like 48% is a 3. I know I cut off at 50. It's like 48, but it depends test to test. That's usually how the breakdown works. And if you're getting sub 35%, you're probably like a 1 or 2. That's about it. If you're showing up late and you missed some of this, don't worry, I did all the questions in here. You should be able to pause and check it out. Your mom got mad at you. Yeah, no, these tests are 2/3 is good. 2/3 is usually safe 5 land. That's how these are written. Why? You got a 16, not a 17. Yeah, but I mean, look over. Okay, out of curiosity, has anybody tried to look this over? I should ask this now. Do they allow you to look at the questions again, or anything like that? Because if they don't, I'm gonna post the tests to Teams so people can look over it. I don't know. I guess this will be posted to Teams, and this has all the questions. So Drew says yes, he can see them, I think. Okay, cool. That's very good. And please read my comments if I gave you any comments, because I put a lot of comments in there saying, like, yo, you would have gotten way more points had you done law. So I forget what those were for everyone, but please read the comments I put for you. I did not write that much for anyone, but if I wrote comments for you, it's probably because you need to fix something before Tuesday, and you will get way more points. All right. Well, hey, have a nice day. Enjoy the sun outside and stuff. I might do that because my wife's done tutoring in like half an hour. So hey. Yeah, sorry, Drew. You already knew about that. All right, bye.